Diagnosing regression, residuals and assumptions. In this lesson, you will learn how to check the quality of a regression model by exploring residuals and testing model assumptions. These checks are important to know if your predictions and inferences are trustworthy. We will explore concepts step by step, with real data, helpful visuals, and practical tips. Running the cell now. What is a residual? A residual is the difference between the actual value and the value predicted by the regression line. It tells you how far off your prediction was for each point. If your model is good, residuals will show some nice characteristics, like randomness and no patterns. Running the cell now. Let us set up our tools for the lesson. We are importing all the needed packages to work with data and charts. We turn off warning messages. We import pandas for data handling and NumPy for math. Matplotlib and Seaborn help us make plots. We load a real dataset about car fuel efficiency. The data is called miles per gallon, which stands for miles per gallon. Here, we look at the shape of the dataset, which tells us how many rows and columns it has. Now, we preview the first 5 rows of the table to see what the data looks like. Running the cell now. Which column do you think could predict miles per gallon? Now we need a clean dataset, so let us fix missing values. We remove any rows that have missing or empty values. We save the clean data as miles per gallon _clean. Here, we print out the number of rows left after cleaning. Running the cell now. Try checking what happens if you do not remove missing values. Building a simple linear regression. Let us predict miles per gallon, or miles per gallon, using car weight. First, we will look at the scatter plot and then fit a model. Running the cell now. Let us look at how car weight and miles per gallon are related. We are plotting car weight on the x-axis and miles per gallon on the y-axis. This scatter plot lets us see how these two variables move together. We set the title to make it clear what the plot shows. We add labels so we know what units we are seeing. Finally, we show the plot. Running the cell now. Can you spot a general trend or pattern? Now let us fit a simple regression model to try to predict miles per gallon from weight. We use a tool called linear regression from Sclearn, which is a popular library for machine learning. We also use a function to split our data into training and test sets. X is our input column, which is weight. Y is our target, miles per gallon. Here, we split our data so we will not accidentally cheat by testing on the same data used to train. Random_state helps keep results the same each time. Next, we create and fit the regression model. We train the model on the training data. Now, we print the intercept and coefficient. The intercept is the predicted value when weight is 0. And the coefficient shows how much miles per gallon changes for each unit change in weight. Running the cell now. What do you think a negative coefficient means here? Let us use the model to make predictions with the test data and check residuals. We use the trained model to predict miles per gallon values for our test data set. Residuals are the difference between the real values and the model's predicted values. We show the first 5 predicted values from the model. We also print the first 5 residuals to see how good or bad the model did. Running the cell now. Are the residuals large or small? Try examining them. Checking residual assumptions. For linear regression, we hope that residuals are normally distributed, have constant variance, also called homoscedasticity, have a mean close to 0, show no patterns, which means they should be independent. Let us check these one by one. Running the cell now. Let us start by plotting residuals against the predicted values. We make a scatter plot of the predicted values on the x-axis and the residuals on the y-axis. If there are no patterns or curves, this is a good sign. We add a red line at 0 so you can see if the residuals average around 0. This helps spot any trends or problems. We show the plot. Running the cell now. Look for patterns. Do points scatter randomly above and below 0? Next, let us check if residuals are roughly bell-shaped or normal. We make a histogram of the residuals, which shows how spread out the errors are. We add a curved line to see the shape. This plot helps detect if most residuals are near 0 and if there are any big surprises. We label the plot. We display the chart. Running the cell now. Do the residuals form a bell curve? Try explaining what you see in your own words. Let us check some summary numbers for the residuals. We print the mean of the residuals. This shows if the model tends to be off in one direction. We also print the standard deviation, which tells us how spread out the residuals are. Running the cell now. Is the average close to 0? You want this value to be small. We can use a statistical test to check if the residuals look normal. The Shapiro-Wilk test gives us a p-value that measures normality. High p-values, greater than 0.05, mean the data looks normal. A very small p-value means the data does not match a normal curve. We print the p-value and a friendly message to say what it means. If the test says residuals look normal, that is a good sign. If not, we may need to fix something. Running the cell now. Try running this for different columns and compare the results. Let us check for equal variance next. The Levene's test tells us if the spread of residuals is similar across predictions. We split the data into two groups and compare their variability. High p-value means equal spread is okay. Low p-value means the spread looks uneven or heteroscedastic. We print results and a gentle message for beginners. Running the cell now. Can you describe what you see in the spread of points in the earlier plot? What happens if assumptions are broken? If the residuals show strong patterns or are not normal, predictions or confidence intervals may not be trustworthy. Sometimes, transformations or more advanced models can help fix these problems. It is always a good idea to check the assumptions. Running the cell now. Let us check for patterns in residuals against the original input variable. Here, we are plotting residuals on the y-axis and weight on the x-axis. We want to make sure the spread is random, not forming curves or funnel shapes. Our red line helps us check the 0 level. We label and show the plot as always. Running the cell now. Practice, try this plot with a different variable as x-axis. One more way to inspect normality is a quantile-quantile plot. A QQ plot compares the distribution of residuals to a perfect normal curve. If points stay near the line, it is a good sign. Large bends away from the line mean trouble. We make and show the plot. Running the cell now. Try explaining what you see in your own words. Let us check for outliers in the residuals. We use z-scores to measure how far residuals are from 0 in standard deviations. If the z-score is above 3 or below -3, we usually call it an outlier. We count and print how many outliers there are in the residuals. Running the cell now. Play with the cutoff value to see its effect. For a detailed summary, let us use another tool, statsmodels. Statsmodels gives us a classic regression summary with lots of details. We add a constant term, then fit the model. the summary includes coefficients, confidence intervals, and assumption checks. We print the report so you can see everything at a glance. Running the cell now. Which statistics in the summary are new to you? Look them up. Now, you can try building a regression with a column of your choice. This cell lets you pick any numeric column in the dataset for prediction. We split and fit the regression again, just like before. We compute and print the mean and standard deviation of the new residuals. You can experiment to see which column predicts miles per gallon best. Running the cell now. Here is a YouTube pro tip: pause, rewind, and experiment as much as you need. And if you like this, like and subscribe. Best practices. Always check your residuals. Make visual plots, not just summary numbers. Test your assumptions, do not just assume they are true. Look for outliers and understand what they mean. These checks make your model stronger and more reliable. Running the cell now. Challenge: try a minute project. Can you check all assumptions with a different variable such as horsepower or acceleration? Try plotting, summarizing, and reporting what you find. Share your findings in the comments section. Running the cell now. Recap. Residuals tell you about your model's mistakes. Good regression models have residuals that look random and normal. Always check model assumptions before using results. Use plots and numbers together for a strong analysis. You are ready to diagnose your regression models. Running the cell now. Thanks for learning with us. Do not forget to like, comment, and subscribe for more easy Python stats lessons. See you in the next lesson. Running the cell now.